In the last presentation, we talked about norm-referenced assessments, and I mentioned criterion-referenced assessments. This presentation will help you learn some of the critical differences between the two types. Norm-referenced tests compare the scores for a large number of test takers. We mentioned before, and you probably have thought of, the bell-shaped curve. Norm-reference tests generally are not tests that only a few people take. These are where hundreds or thousands of students take a similar test. What is good about a norm-reference test is we can compare one individual to a large group of comparable individuals. With norm-reference tests, the mean divides the distribution of people. The raw scores then are recorded across the bottom, and as you can see also, standard deviations are listed. The scores are the 70, 80, 90, 100, 110, etc. 100 on a norm reference test is the average, it's the mean, it is where the majority of the people have scored. The standard deviations are noted across the bottom underneath the scores. 0 is the midpoint, and then off to the right, +1 indicates 1 standard deviation, +2, 2, etc. And on the opposite side, on the left, -1 is 1 standard deviation below the mean or the norm. Very useful statistic is percentiles or percentile rank. Percentile is a point along the normal distribution of scores. It is most meaningful when used with a norm reference test. For example, an intelligence test, COGAT, ITBS. Most commonly confused with percentile is percentage. They are not at all the same thing. The percentile is another form of a raw score. It's a portion or a ratio. Percentile or percentile rank is very simple to calculate. The percentile equals the number of observations or scores that are lower than whoever you're looking at, divided by the total number of observations times 100. So if there were 50 people taking a test, that would be the N. The total number of observations would be 50 test scores. B would be obtained by ranking them from the highest to the lowest. And say you're looking at the top score. How many scores are lower than that? Then you would be able to calculate. We'll do some practicing on this in a little bit. After this presentation, look in your files and you will find an Excel spreadsheet that is called Sample Data Sheet. You're going to choose a student's name and you're going to calculate the percentile for that student. If you get confused, go back to your textbook. The chart that we are using comes directly from Chapter 5. So if you're not quite certain, reread that section and you will be able to work on the calculations. Now here's a quick quiz. Why can't you be at the 100th percentile? Well, because if you are the highest scoring, you're not included in the calculations. We're only looking at the people beneath you. So there is no way, if you're at the top of the list, that we can calculate a percentile to be 100. The next type of test we're going to look at is a criterion reference test. In this case, there's already a predefined level of performance that a student must hit, what we'll call an absolute performance level, to pass the test. You think about some criterion reference tests that you're familiar with in their absolute performance level. For example, a driver's test. You have to be able to master and demonstrate your ability to turn right, turn left, potentially parallel park, or go through an obstacle course. If you hit a certain criteria, then you pass. One of the things that you have to be careful of with the Criterion reference test is the norm reference statistics can be calculated because they're just math, but this is not useful for a Criterion reference test. So again, while you could calculate statistics like percentiles and quartiles and stanines, it's not very helpful with a Criterion reference test. Okay, did you come up with any of these when you were thinking of Criterion reference test? Look, driver's test, that was my example. Pass-fail test. The WKCE CRT, which stands for Criterion reference test. A classroom quiz or a test. Explore, plan, and ACT. If you're thinking about their readiness scores. Are there others? Here's an example of a Criterion reference test, the WKCE. Now I'm using the old cut scores on this example. How can I be advanced on the WKCE and also at the 35th percentile? Remember that the 50th percentile is average. The case is that because the WKC is a Criterion reference test, anybody can obtain the criteria. Therefore, the distribution shifts dramatically. Sometimes this is called a J-curve. On a norm reference test, you will always have the standard bell-shaped curve. In a Criterion reference test, since everyone has the ability to work towards the criterion, the distribution of students taking it shifts, as you see here. Very recently, the WKCE obtained new cut scores, so the results on the WKCE parallel the National Assessment of Educational Progress, called NAEP. This was done in the state of Wisconsin to meet federal criteria on our ESEA waiver. A concern that was had by the federal government is that our students scored much higher on the WKCE, but those same students, when they took the NAEP, scored much lower. So what was done was they correlated the scores from the WKCE to match more closely to similar performance on the NAEP. That change has impacted the distribution of performance, and it looks a little bit more bell-shaped currently. Don't mistake that this test is now norm reference because the distribution is more normal. It's still a Criterion reference test, and over time, the distribution will shift and take on that J-curve appearance. Here is just one example of the change. On the left, the old cut scores on the fourth grade WKCE reading test for school, and the new cut scores that are more correlated to NAEP. You will see there has been a dramatic shift from the old to the new. This is causing a change in thinking in schools about what is proficient. What should a student be able to do in each grade level in their abilities in math and in reading? These new cut scores only impacted the reading and the math tests, and the reading was most dramatically impacted, as you can see between the new and the old distributions.